These are the solutions to Chapter 10.2 Hypothesis Tests for Population Proportions written homework. So we'll start with problems 4, 5, and 6. They're very similar questions. In order to conduct a hypothesis test, um, um, remember that there's a series of steps we do. We identify the null hypothesis, alternative hypothesis. We then determine what level of significance are we going to run the test at. We then determine critical values, the p-value from the critical value, and then decide do we reject or fail to reject. So that's what we're looking at. So the first thing here, these problems 4, 5, and 6 are just to identify the critical value at each of those cases for the 3 different types of tests. So for number 4, we're looking at a right tail test, which means that what's going to happen is that we're going to collect some sample data. In this case, we're talking about proportion. So we'll end up with some sample data. We'll have the proportion, and then we get some sample data. Right tail test means that we're going to be looking at the right side over here. And then alpha equals 0.01, so the area is equal to 0.01 over here. So we're trying to look for this critical value, this z value right here within that. And again, the picture that goes back to, just to refer back to our notes real quick, looking at what we did in note sheets somewhere here. There we go. This is what we're looking at here. We're calculating we're looking for the critical value that has an area in this right tail of alpha equals 0.01. And we're not dividing by 2 in this case because it's just a one-tail test, right tail. So that's what we're looking at. And so in order to answer that question, we got to go to StatCrunch. You're going to go to normal calculator. We've done this math before already, or these steps. And then I'm going to put 0.01 here and then compute. And so then we get our answer for the critical value right there. Oop, I went to the wrong side. Turn that to greater than. This is what you guys do too, sorry. 0.01 right tail, greater than symbol, compute, and you get 2.33. So for this first one, the critical z is equal to 2.33. And so you have that. Now, if we run a left tail test, number 5, if we were going to run a left tail test, number 5, let's change the color. If we were going to do a left tail test, number 5, we're going to look for the z right here, where this is alpha equals 0.01. And so then we go ahead and, oh, sorry, not 0.01, but 0.1. That's a 10 there. So the alpha in this case .1 or 0.10. This is what we're looking at. So you would go ahead and go to StatCrunch. I'm going to put 0.1 here, and then I'm going to change that to the left tail. So then you have that there, and you get negative 1.28 is our critical value for that one there. So for number 5, the critical value is the critical z is negative 1.28. And then for number 6, it's a 2-tail test. So in this case, for number 6, we're going to look at the normal distribution. We're looking for 2 tails. Alpha equals 0.05. So what we need to do is we need to divide that into 2 pieces. So this becomes 0.025 in the area here and 0.025, and now we're looking for the critical z values. This time there's a 2 tails, so we're going to end up with 2 values in this case. So there's multiple ways we can do that. One way is to use the between, clean that off, and put 0.05. That's one way to do it. Compute. Bad, messed up. 0.95 because in between. So that's your 95%, at least 2.5 in each side. So we get answers at negative 1.96 or positive 1.96. Another way would have been to clean that out and put 0.025 like that. And there's your negative 1.96. And then, or if I clean that out and do the right side, you get 1.96 again. So our answer for number 6, the critical z values, there's 2 of them. They're going to be 1.96 and negative 1.96. I could have written it as this 1.96. There you go. Let's go ahead and look at number 20. Let's actually go run a hypothesis test here. So in this case here, 2001, December, 38% of adults with children under the age of 18 reported their family ate dinner together 7 nights a week. In a recent poll, so we're going to be comparing this number to this number here. In a recent poll, 403 out of 1122 adults reported they eat dinner with their family 7 nights a week. Has the proportion, there's the key question, has the proportion of families with children under the age of 18 nights decreased? And so how do we start a hypothesis? 1, I need to know what p hat is. So p hat's going to be 403 over 1122. We need to get that value. Okay, that's the first thing. The next thing is step 1 is we need to know what the alternative hypothesis, null hypothesis and alternative are. So in this case, we're saying the proportion of families who eat, if there's been no change since 2001, so that value, that the proportion we're looking at is 0.38. We're now asking, has that proportion decreased since, has there been a change? And so here it is, the proportion is less than 38. And so what we need to do next is let's the value of p hat. And so we're going to do 403 divided by 1122, and I get a value of 0.359. And so right now we do have some evidence potentially that the proportion has decreased. What's our evidence for the alternative hypothesis? Is that our sample, right? Here's evidence. This is evidence, but is it enough evidence? So this is evidence for H1 that this is true, but we have to run the hypothesis test to figure. So we're going to run it at the alpha equals 0.05 level, meaning that when we make our decision here, we have a 5% chance of being wrong, an error. It's like a confidence interval. Step 3 is we need to find the z statistic. And then with that, we end up finding a p-value. So in order to do that z statistic, again, there are 2 ways to do it. If you're going to do it by hand, it looks like this. There it is, where you calculate this value, p hat minus p, which is the value that we had here, 0.38. And so we would plug that in. The other way we're going to do is use technology, and then we check to see if the p-value is less than alpha. And so in this case, what we do is you go to proportion stats, one sample with summary. Number of successes was, let's go back, number of successes was 400 and solutions. Was it 403 over 1122? So 403 over 1122. We're comparing that it is 0.38, and we're saying, is it less than 0.38? And you just compute. And so then we end up with those values there. Your z statistic is negative 0.1436 or negative 0.144. So that's what we would have there, negative 1.44. The p-value associated with that test statistic is 0.0754, 0.0754, 0.0754. So we have those values there. And then step 4 is then to make a conclusion. So in this case, do not reject the null hypothesis because, why? Because the p-value is greater than alpha, right? What are we talking about again? Alpha 0.0754 is greater than 0.05. So do not reject this. So we're saying we don't have evidence. We're rejecting that and not rejecting that. So what we're going to then conclude, we then have a conclusion, right? What's our step number 5? Step number 5 is to write a conclusion, and we're going to say what we're going to say in the conclusion is there is sufficient evidence or there is not sufficient evidence to conclude that the alternative hypothesis, whatever that is. In this case, we don't have sufficient evidence to conclude the alternative hypothesis um, to support the alternative hypothesis. And so that's what we're going to end up saying here as the conclusion for the homework question there. So we end up saying there is not sufficient. We said we had some evidence potentially because this is smaller, but we do not have sufficient evidence due to the p-value. We do not have sufficient evidence to conclude that p hat is less than 0.38. We don't have enough evidence to conclude that, which is, again, that the proportion of children with families under the age of 18 eat dinner with their family 7 nights a week, that it's decreased. We don't have enough evidence to say that is true. Let me write that better. There we go. Let's finish this up. Number 26, another hypothesis test here. In an American Animal Hospital Association survey, 37% of respondents stated that they talked to their pets on the telephone. A veterinarian found this result hard to believe. So he randomly selected 150 pet owners and discovered that 54 of them spoke to their pet on the telephone. Does the veterinarian have the right to be skeptical? So the veterinarian does a p-hat. He does a sample. He found 54 out of 150. And so we get that value there. Step 1 would be to write what the null hypothesis and alternative hypothesis are. And so we have, first let's calculate the p-hat and see if there's any evidence. He gets 0.36 and the hospital survey was 37. So is there evidence, right? I don't want to put it equals here. That's bad notation. If we have this here, right here, P is equal to 0.37, meaning nothing's changed from the original survey. The doctor really thinks that it's less than that. He's skeptical, right? So does he have evidence? I say there's some evidence, but 0.36, but I'm not sure it's strong enough, but let's go ahead and calculate this. We're going to test it at the alpha equals 0.05. Step 3 is we need the z value, and then from there we get a p value. And so the z value, we go ahead and run this test. Go back to here. Let's change this up. It was, I already forgot the numbers. For 26, it was 54 successes out of 150. And we're saying it's less than 0.37. That's what we're doing, another left-tailed test. And we're saying, is it less than? Get a z of negative 0.25 and 0.399. So you get a z of negative 0.25, and then if we round up 0.40 p-value. And so in this case, step 4, what's our decision on step 4? Step 4 is to say do not reject H naught since the p-value is greater than alpha, right? The p-value is 0.40. It's greater than 0.05. So do not reject that. Reject that. That is not enough evidence. There's not enough evidence to conclude, right? So there is not sufficient evidence. Sufficient evidence to conclude that P is less than 0.37. We don't have enough, which means that the veterinarian does not have the right to be skeptical. This question here. Does the veterinarian have the right to be skeptical? The answer is no, because there's not enough evidence to say it's less than 0.37. That's the answers for chapter 10.2.